Yellowstone National Park has a supervolcano. It's about 43 by 60 miles across and 12,000 feet deep. If it blew up, much of the western half of North America would be covered in ash. It could also kill over 10,000 people. But really, we should consider ourselves lucky that this thing exists at all. The truth is that our planet could have many, many more supervolcanoes than it does now, and some of them might even be hiding right under our feet. Welcome to my channel. And today we are answering the extraordinary question, what if Earth had many more supervolcanoes? First off, we need to figure out what makes a volcano a supervolcano in the first place. A volcano needs three things: hot magma or molten rock beneath the crust of the Earth, a weak spot in the crust through which the magma can reach the surface, and some sort of eruption mechanism to push the magma upwards. Some volcanoes erupt explosively because gas bubbles in the magma expand rapidly, creating pressure that bursts the outer shell of the magma chamber. Others have more viscous or sticky magma that clogs their exit holes, which also generates pressure. This can cause an explosion when the pressure exceeds the strength of the surrounding rock. Yet others have no explosive eruptions at all. Instead, they have what's called a lava lake, basically a pool of lava that spills over the sides of the volcano when it reaches a certain level. All of these mechanisms are rare, which is why there aren't that many active volcanoes on Earth in the first place. They require unique combinations of chemistry, depth, geology, and geography, so we can probably rule out the possibility that new volcanoes will form anytime soon. But there's nothing stopping existing volcanoes from getting bigger. For example, imagine a giant plume of hot rock rising from deep within the Earth, melting the weak rock layers above it, and creating a huge magma chamber. If that magma chamber were to fill up enough, the overlying crust would buckle and dip. Eventually, the central part of the magma chamber would drain, and the crust would snap back into place, pushing the surviving magma upwards to form a mountain. With each new intrusion, the magma chamber would grow larger, and the magma would solidify into a vast igneous batholith, a mass of intrusive igneous rock that often forms the foundation of mountain ranges. These batholiths can be absolutely enormous. For example, the Sierra Nevada batholith covers an area of over 24,000 square miles in eastern California. That's nearly the size of Maryland. So what if that batholith contained a gigantic magma chamber big enough to blow? Well, it already does. Deep beneath the modern Sierra Nevada mountains lies the Long Valley Caldera. It formed about 760,000 years ago, when the magma chamber beneath the Sierra Nevada batholith finally erupted in one of the largest volcanic events in history. The explosion left behind a caldera nearly 20 by 30 miles across and 4,000 feet deep. Since then, the caldera has been filled with younger volcanic rocks, forming a new mountain range nearly as tall as the original. In other words, the Long Valley Caldera may be sitting on top of a supervolcano that has already blown up once before. But that's small potatoes compared to what's happening beneath New Zealand. There, the North Island sits atop a gigantic hotspot that has been volcanically active for millions of years. Over time, the island has grown steadily larger, as successive eruptions added layer upon layer of solidified magma. But unlike the Sierra Nevadas, the North Island has a single weak point that connects the magma chamber below to the surface above. About 26,000 years ago, the pressure inside the magma chamber was great enough to rupture this weak point. It blew up so violently that the North Island actually fell into the Pacific Ocean. Fortunately, it landed on a continental shelf, which prevented a major tsunami, but the eruption itself was so large that it's possible that ash reached as far away as Antarctica. Today, the North Island is home to dozens of geothermal features, such as geysers and mud pools, and scientists believe that it could host one of the world's largest supervolcanoes. This is a big deal because New Zealand has a population of over 5 million people. So a massive eruption here would be truly catastrophic. Now, you might think that most countries would take such threats very seriously, but you'd be surprised. For example, Mount Vesuvius is famous for burying the Roman city of Pompeii in ash in 79 AD. But there's another volcano that rivals Vesuvius in both height and destructiveness. It's called Santa Maria de los Remojados, and it's located near Lake Nicaragua in the country of Nicaragua. Although it hasn't erupted since the 16th century, its summit is still smoking. And it's just one of 5 volcanoes in Nicaragua that could erupt at any time and kill hundreds of thousands of people. This isn't just some third world country either. Nicaragua is located in one of the wealthiest regions on Earth, Central America's so-called Golden Triangle. Yet despite the threat of volcanic eruptions, only one of Nicaragua's 5 volcanoes is being monitored. And that's not enough. In fact, there's a good chance that we're missing even bigger threats. Most of the world's supervolcanoes are hidden beneath oceans where we can't see them. We do know that there are at least 2 gigantic calderas beneath the seafloor of the Pacific Ocean. One is the 60-mile-wide Toba caldera in Indonesia. It blew up roughly 74,000 years ago in an event so violent that it caused an ice age. Another is the 50-mile-wide Chelopevtsev bank, located east of Russia. This one erupted around 100,000 years ago, and may have been even more powerful than Toba. We don't know how many more submerged calderas exist, because we haven't explored that much of the ocean floor yet. Even if we did, though, we couldn't stop there. Supervolcanoes aren't limited to our planet. They occur throughout the solar system. For example, Io is a moon of Jupiter that is volcanically active due to tidal heating from Jupiter's gravity. The problem is that the solar system is moving towards a region of space known as the Great Filter. As the Voyager probes pass the orbit of Neptune, they'll begin encountering a wall of space debris. NASA believes that the debris is from countless comets and asteroids that have been destroyed by Neptune's gravity. If those bodies contained volatile compounds such as water, then the debris will also contain water vapor. And wherever there's water vapor, there's a potential for supervolcanic activity. In other words, the further out Voyager travels, the more likely it is to encounter a super eruption on Io. It's a relief, therefore, that the Voyager probes won't be around to witness the event themselves. Both probes will run out of power long before they reach Neptune. Luckily, though, we won't have to wait long to find out, because it's already happened. Scientists recently discovered a 400-mile-wide dark spot on Io's surface. Using NASA's Hubble Space Telescope, they observed active volcanoes surrounding the dark spot. All of them are centered around a gigantic magma chamber. Scientists estimate that the chamber extends 200 miles beneath the surface of Io. It's so massive that it could produce the largest volcanic eruption in the history of the solar system. And, unfortunately, Io is just one of several moons in the solar system that could erupt in spectacular fashion. Saturn's moon Titan is home to vast lakes of liquid methane. When they evaporate, the methane forms clouds that could generate tremendous amounts of energy. If the clouds were thick enough, they could trigger gigantic storms that rage for months or even years. Meanwhile, Jupiter's moon Europa is covered in a layer of ice that's just waiting to be melted by the tidal heating from Jupiter. The resulting water vapor could form an atmosphere and fuel enormous volcanic activity. Finally, Neptune's moon Triton is slowly freezing as it moves farther away from the Sun. As the nitrogen in its atmosphere condenses, it could trigger a massive ice age. It's pretty clear then that supervolcanoes come in all shapes and sizes, and not just on Earth or anywhere else in the solar system. With a little imagination, we can come up with all sorts of hypothetical scenarios that could lead to unprecedented eruptions. For example, what if a comet struck the Earth at the same place that the Chicxulub asteroid struck 66 million years ago? If the comet were big enough, it could melt the entire North American continental crust, triggering a massive flood basalt eruption. Or what if the magma chambers beneath Yellowstone and the Long Valley caldera somehow connected? If that happened, the Long Valley caldera could blow again, but this time with twice the explosive force. It could eject over 2,000 cubic miles of ash into the atmosphere. This would be so bad that it might actually kill us all. Obviously, though, those scenarios are just made up. The truth is that it's impossible to say what a super eruption would look like until it happens. That's why scientists are constantly searching for new and creative ways to study our planet's existing supervolcanoes. The more we learn about them, the better prepared we'll be if one of them blows. Because, while life on Earth would never be the same after a super eruption, it would also go on. If you enjoyed learning all of this stuff, you should check out another video on my channel called What Happens to Your Body After You Die, or check out this other video. Thanks for watching.